recording for this. All right, so we're going to try to do slope at a point, and we're going to use a spreadsheet to make the calculations go along a little bit. Let me zoom in. Oops, come on, zoom in, please. One more time. All right, so the things I got going on here is I have an X value going on. My Y value is X squared. So I'm just making notes to myself what I'm doing, and then I have the slope M in this column right here. And I'm starting at the point 1, 1, so I'm just going to enter that in there. And I can't do a slope at a single point because slope is rise over run, and I need another point. So this time we're going to take values that are less than 1 and work our way toward 1. So maybe I'll start all the way over at 0, 0, and then I'll start approaching 1 from 0. So maybe I'll go to 0.5, and then 0.2, and then 0.1, 0.01, and one more. Let's go 0.001. So those are the X values I'm going to plug in, and then I'm going to calculate the Y value and calculate the slope. So let's start over here with the slope. So to make a calculation on a spreadsheet, you start with an equal sign. And then because this is a complicated fraction, I need parentheses to start the numerator. And numerator is change in Y over change in X. So I'm going to say, okay, take this Y value. So I can just click on it, dash for minus, and then click on that Y value, close the numerator. And divide, order matters, parentheses for the denominator, take the second X value and subtract the first X value. And that's just a point and click. You have to use a spreadsheet for this? No, but otherwise you're retyping the same thing over and over on your calculator. So this is a bit more efficient, and I'll show you why it's more efficient. So now the calculator, the spreadsheet is a calculator, and it says, hey, the slope between 0, 0 and 1, 1 is 1, right? And that's fairly obvious once we look at that. So I'm just going to continue. I'm going to make the calculation for the Y values here by just saying equals, take the corresponding X value and raise it to the second power. And Google is saying, hey, you want to autofill? I'm just going to say no for now. Once you have a formula typed and you're going to do a similar thing in other rows or columns, you can just use that little tiny blue button in the bottom corner there. Notice my cursor changes shape to a plus. If I click there and drag, it will recopy the formula, sort of. I got to fix it a little bit. And it shifts the cell references down. So originally, it was grabbing these 2 points. Now here, it's grabbing those two. Now I wanted to actually reach back and get the point 1, 1 each time. So that means this didn't quite work the way I wanted. So I got to fix it. So the way to fix it is to tell it to always grab this point here. Move this out of the way. I always wanted to grab the point in row 2. So to make that happen, I have to sneak in between the B and the 2 here and throw in a $ to say, don't touch the 2. I always want to look in row 2 for that point. And same thing here for the X value, because I have to have a corresponding Y and X value when I do the slope. So I just modified my formula by saying the first Y value is whatever row I'm in. The second Y value is always row 2. And that's what the $2 means. So that has to go in each place. So now when I fill that formula down, it's always going to grab that top one. Okay, so if I do that again, now there is no calculation here, so I can just throw in an equals X squared. And again, spreadsheets are nice because if you tell it to use a value in a particular cell, it'll update when you do that. So for example, this says, hey, grab the number in A5. If the A5 instead was 0.25, then it's going to automatically update the Y value because the Y value says, hey, square whatever's in the cell to the left. All right, let's make that back to 0.2. And so when I fill this down yet again, double check, it's going to grab the current point and always use the point in row 2 because of my $signs there. So if you're not familiar with a spreadsheet, hopefully this is a useful idea. And it's these 2 formulas I want to keep repeating so I can highlight the 2 of them at once, then point to that autofill button and drag it down. And it will make all those calculations for me. So I can see here that as if I stick at the 0.11 and then I pick X values that are getting, ooh, I went the wrong direction. I wanted to go toward 1, not away from 1. All right, so let's fix this. So from 0.5, maybe go 0.9, and then 0.99, 0.999. So again, I'm trying to get closer to X equals 1, that's the goal. 9, so I'm getting progressively closer from 0 toward 1. And I can see the slope here is moving toward, what number would you guess we're approaching? Anybody? 2, thank you. Yeah, this looks like it's getting closer to 2. And earlier, Cole asked, you know, how can we be sure? And this repeating 9s, it makes me pretty sure that I'm approaching that. But we're not always going to recognize the number we're approaching. It could be some weird decimal that we're not familiar with. Like, I don't know, maybe we're approaching something like 2.781828576. And like, what number is that? Have I seen that number before? Do I know that number? Or maybe we're approaching a number that looks like 3.1459. That number looks kind of familiar, not sure. So the question is, how do we know? And so what we have to do is we have to build up a system that allows us to say, it's approaching this number. I don't have an easy name for it like 2, but maybe it's like pi or pi over 4 or e or the square root of 3. So there's lots of other numbers we might find out there. And not all numbers have special names that are easy. It just kind of depends on the number. And we'll, again, approach that later. So a spreadsheet is a nice way to systematically look at a pattern of numbers. Otherwise, you're over and over on a calculator repeating a pattern of a calculation like I was doing here in my Google calculator. So it's kind of nice. And I use a spreadsheet often. So this is, I'm trying to figure out slope at a point. So it's a good idea to name your files. Okay, we are running down toward the end of time. Could you find the slope of the main point and find out 1 unit forward and 1 unit backwards and subtract them and find the slope? So I think, Cole, you're asking if you put a point on each side of the main point? Yeah, that's what it looks like you're doing there, right?
Okay, I was mistaken in saying that you subtract them, but I was noticing that like with the 0.24, if you set it on the 0.24, like you could only technically guess that it's 4, but like one way that I found out is that if you go to the point, which is like 1x unit to the right, which ends up being 3.9, it's exactly 5. And then if you go to the one that's 1 unit from the x back, which is 1, it's exactly 3.
And 4 happens to be right in the middle.
Yeah.
Yeah, and that's the thing we're trying to get at, is how can we find some kind of system that allows us to make a very good educated guess? And there's lots of ways to go about it. So just to kind of sum up what we're looking at here, and again, we came up with a couple of approaches here, being fixed at the point we're interested in or being on each side of the point we're interested in. And it's usually a good idea to do both, all right? And that idea of doing both is what we're going to be playing with throughout this chapter. And where did my notebook go? Okay, so summary of what we're looking at. So if I do something like I start with a curve, and I want to find how the slope changes or what the slope is, at a point. The fundamental issue we come across right now is we need 2 points to find a slope. We don't have any other way to do it at the moment, right? Yes, and I'm going to end, just got a couple more things to say, and I'm about to end here. So we need 2 points. Starting with a curve and using 2 points to find the slope, that's called a secant line. So a secant line is a line that intersects a curve at 2 points. If we try to whittle that down to 1 point, and that in this case, it's a 1 point estimate of the slope. That 1 point estimate of the slope, a line that touches a curve at 1 point, is called a tangent line. And we're trying to morph a secant line into a tangent line, but we always have that a problem is at the tangent line, we're dividing by 0, and that's a problem. And the idea of getting those points to approach each other is the idea of a limit. And so what we're going to do is we're going to explore this idea of a limit so that we can get some kind of definite answer and it not be just a guess. And so this section 1 was just, okay, here's the problem in calculus, turning a secant line into a tangent line, and then how do we definitively come up with that answer? And that's the idea of flushing out what it means to have a limit as in a sequence of values. What is that sequence of values approaching? And so that's what the next few sections are about, getting this definite idea of a limit. All right, so that's it for today. We're gonna end only 2 minutes over. Sorry about that. Someday I'll be more on time. Stop the share here. So we got a couple of recordings. They'll go into the YouTube playlist, which is now linked in the syllabus. I will see you all tomorrow. Message me if you have any questions.